What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 9.3, similar right triangles. And of that, we're going to identify similar right triangles, solve real life problems involving those things, and then also find geometric means of two numbers. So let's get started by looking at our first theorem. This is on your theorem sheet. You might want to copy down just the pictures and similarity statements that I have here. It just states if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if we have the original triangle ABC, I want you to think about this one as this big triangle here, A, B, C. The altitude is D right here, alt, okay? So if the altitude is drawn to the hypotenuse, so C is drawn making this D length, and that's creating that hypotenuse AB, then the two triangles formed are similar to the original triangle and one another. So here are the two triangles that are being formed. ACD is this red one, and DBC is this blue one, and they're all going to be similar to the larger triangle ABC. Okay, so make sure you have this picture, the pictures drawn here. That helps you kind of visualize it. And then what we're going to do now is break it up and identify some similar triangles. So each one of these, we're going to be able to identify three triangles that are similar. So the first thing we want to do is go ahead and identify the larger triangle. So larger triangle is QRS, and that is going to be similar to triangle QST. Okay, so QRS, QRS, and then QST. Notice how I'm ending with the 90-degree angle. So the last triangle, if I end with a 90-degree angle, it would need to be SRT, or you can do RST. Okay, so all three of these would be similar. See if you can try the next one here. So go ahead and start with your big triangle. Triangle EFG is similar to what two other triangles? So another triangle that it's similar to is GFH, ending on that 90-degree angle. And then the final triangle we're similar to is EGH, ending on that final triangle. Okay, so really the last letter we're getting to is this letter H, because it's showing that altitude with that connecting from the hypotenuse. Okay, the last one we should see triangle RST is similar to triangle RTU, ending on that 90-degree angle at the altitude, and then is similar to triangle TSU. If you wanted to, you could also say STU. Okay. Next up, we're going to look at these. It says a roof has a cross section that is a right triangle. The diagram shows the approximate dimensions of this cross section. So again, this cross section is essentially showing the altitude. Okay. Find the height H of the roof. So we know that this larger triangle, ZYX, I'm going to go ahead and draw it, has 6.3 meters, 5.5 meters, and 3.1 meters. Okay, and it is similar to ZWY. I know that this is 5.5 meters. I don't have enough information to know ZW, but I do know that that is representing H. Okay, and then if I wanted to, I could draw this other one, but what I mainly want to focus on is how these connect. So W is showing this right angle for the first, or the smaller one, whereas angle Y up here is showing the right angle for the second one. Okay, so you may want to picture this as kind of flipped upside down. So if I maybe redrew the larger one. Here is angle Y with the right angle, and that would mean 5.5 meters is here and 3.1 meters is here. What I'm trying to do is just get oriented with the numbers that can match, okay? So if that's the case, then I just need to figure out, and then this would be 6.3, right? Okay, so this is Y, this would be Z, and this would be X, okay? So YX is still 3.1, and YZ is still 5.5, and ZX is still 6.3. So now you can see that I have some similar or some corresponding sides. So if I wanted to find H is here, I could say 5.5 over 6.3. So 5.5 to 6.3 would be represented H to what? Okay, so we're going to try to figure out what that matches with. So 5.5 is matching with that 6.3. Okay, and then H is matching with that 3.1. Okay, so as we solve this, we're just looking at it as a similar triangle where we can set up a proportion, cross multiply, and then solve it. Okay, so we have H over 5.5 . Here, let's try this one more time. H over 5.5, and then 3.1 over 6.3. So this is another way that you could set it up too. Okay, so H to 5.5, and then 3.1 to 6.3 is our two matching or corresponding sides. We're going to cross multiply, so I get 6.3H is equal to 5.5 times 3.1 is 17.05, and then I divide both sides by 6.3. So divide by 6.3, I'm getting about, we'll go ahead and round it, H is about 2.7. Okay, so the tricky thing is making sure you're lining up your triangles correctly and finding out where they match. Okay, we're going to try some more simple ones. That one was kind of tricky to start off with because you had so many decimals. Let's try these. Find the value of X. So we have X over 4. That could be a triangle. Okay, or they can match. Is equal to 3 is the big one over 5. Okay, so again, I want you to kind of picture this as two separate triangles. Okay, the X and 4 belong to G, H, F. G, H, F, where H is that right angle, and this is an X, and this is 4. Okay, then you have this larger triangle, E, G, and F, okay, where this length is 5 and EG's length is 3, but this right angle is at G, okay? So if you look at maybe across from the right angle is 4, across the right angle is 5. So see how 4 pairs with 5? So that means X has to pair with 3. Since they are not a part of the right angle, they're a part of a leg, okay? That might help you make a little bit more sense out of it. Find your right angle. Those two things are matching, which means the other two would be matching, okay? So when I cross multiply, I'm going to get 5x is equal to 12. Divide both sides by 5. X is 2.4, okay? Maybe see if you can try this one on your own, see if you feel a bit more confident. When you're done, go ahead and click play. So let's pause this one, try it on your own, check it by clicking play. All right, one way you can do this is just draw your two separate triangles. So I have J, M, and L. Here's my right angle. JM is 12. JL, is 13. Okay. And then I have my smaller triangle. Here's M, L, and K. Right angle is here at K. I have KM is X, LM is 5. Okay. Again, where I start is to see what number is across from the right angle. So 13 will correspond to 5. Okay. So that means 12 corresponds to X. See that? Cross multiply here, 5 times 12 and 13 times X. So I'm going to get 13X is equal to 60. And then dividing both sides by 13, I'm not going to get a nice pretty decimal here, I don't think. 60 divided by 13, yep, gives me about, we'll round it and say X is approximately 4.6, or you can even say 4.62. Okay. So again, redrawing the triangles and finding your right angles first and corresponding right angles together, or the hypotenuse, that would be helpful. All right, the next thing we're going to talk about is the geometric mean. The geometric mean of two positive numbers, a and b, is a positive number x that satisfies a divided by x is equal to x divided by b. So to find that, you can find x by taking x squared, because that's x times x is equal to a times b, where x all by itself would be the square root of ab. Okay, so we're going to apply that with the next few examples we see on our paper. If you need to, you can pause right here to write this down in your notes or on your theorem sheet. Whenever you're ready though, let's go ahead and click play. So what we're going to do, we're going to pretend that this is A and this is B. So first things first, just make sure you know A and B. And according to my geometric mean, I can find X, which is my geometric mean, by finding the square root of A times B. So what I would do is I would set X is equal to the square root of 12 times 27. Okay, 27 times 12 is going to give me 324. So I'm going to find the square root of 324, and that's actually a perfect square. We're going to get 18. Okay, if you want to, go ahead and try the second two on your own. If you're not ready on your own, let's keep working together. The next one, x equals the square root of 18 and 54. We're going to take 18, multiply that by 54, we get 972. Now if we type in 972 and try to find that square root, let's see, 972 square root is not a perfect square, so we got to find some perfect squares here. Initially, you're not going to find perfect ones right away, so what I did is I broke it down into things that I could break down as well. So I broke it down 972 as the square root of 18 and the square root of 54. So if you take 54 times 18, you're going to get 972. And then from there, I did the square root of 9 times the square root of 2. And then 54 is the square root of 9 and the square root of 6. The square root of 9 is 3, so I have 3 square root 2. Taking up too much space for this one. 3 square root of 6, and then I'm going to multiply 3 times 3, which is 9. And then 6 times 2 would be 12. So square root 12 times 9. But then I could rationalize 12 even further. That would be square root 3 times the square root 4. So this is 9 times 2 times square root 3. So this would be 18 square root 3 as a rationalized number. Or if we took that and found just the square root right away, it'd be about 31.2. Okay. Then our last one, 16 and 18. This one we just take the square root of 16 times 18. 16 times 18 gives me 288. But this is not going to be a perfect square, so if you type that in, you get a decimal. So to rationalize it, I had broke it apart and said the square root of 16 times the square root of 18 again, because to make square root of 16, that's just 4. To make the square root of 18, that is the square root of 9 times the square root of 2, or 3 square root 2. And then times 4 gives me 12 square root 2, which is approximately rounded 17.0. Okay? Next up, we have 2 more theorems that we're going to look at, and then we'll be finished up with theorems on this lesson. Geometric mean, or the altitude theorem, just states if you have the triangle ABC, so what I would do is go ahead and draw a triangle and label it ABC as a large one, but then create your altitude as D. So D represents altitude. In order to find this geometric mean using a triangle, you can use that right triangle, find the altitude from the right angle to the hypotenuse, that is dividing the hypotenuse into 2 segments, AD and DB, okay? The length of the altitude is the geometric mean of the lengths of the 2 segments of the hypotenuse. So in order to do that, we can do CD squared is equal to AD times BD, similar to how we were just seeing our geometric mean before and said we were using X's, A's, and B's. The geometric leg theorem states that in a right triangle, the altitude from the right angle of the hypotenuse divides the hypotenuse into 2 segments again. So that is forming those 2 segments, AD and DB, one more time. However, in this case, the length of each leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So you can flip it around and say, if I know CB, I can take CB squared, and that is equal to DB times AB. Or if I know AC, that is equal to AC squared is equal to AD times AB. It's just that adjacent leg, okay? Both of these things would be good to draw on your theorem sheet. Once you're done drawing that picture, let's try some together. So what we're going to look at here is finding the value of each variable. And what I always do first is I'm going to go and label A, B, and C. So this I'm going to say is A, this is B, and I'm going to say this is C because C is connecting and making that altitude, and we're going to name that D. So we know that we can take CD, which is unknown right now. CD squared will be equal to AD times BD. So what I'm going to do is I'm going to say CD is now x squared is equal to AD 9 times BD 4. I'm going to get x squared equals 36. So that means x is equal to 6. Okay? So this is another way to find lengths of a right triangle built together. Again, starting up again here, I'm going to say this is A this time, here's B, here's C, and then D would be this length. Again, CD is unknown, so CD is what I want to set it equal to. CD squared is equal to AD times DB. So that's x squared equals 6 times 3, which x squared meaning that's 18. And then I just find the square root of 18. The square root of 18 could be broken down into the square root of 9 times square root of 2, which is 3 square root 2. And then our last one, a little bit different. So this is still A, this is still B, this is still C, here is D, but notice that BC is missing, or CB. So according to this up here, CB squared is equal to BD times BA, right? DB times AB. Or BD times BA, okay? So same type of deal. So don't know CB, so that's y squared is equal to BD, which is 2, times BA, which is now 2 and 5, which makes 7. So y squared is equal to 14. So y is equal to the square root of 14. Can't rationalize that anymore because the only things that go into 14 are 2 and 7. Square root of 2, square root of 7 cannot be unrationalized, so we're going to keep it as y is equal to square root of 14. Okay? And then last one, to find the cost of installing a rock wall in your school gymnasium, you need to find the height of the gym wall. You use a cardboard box or cardboard square to line up the top and the bottom, essentially showing this picture here. Approximate the height of the gym wall. So if we label this as A, B, C, and this is D here, we do not know what AD is equal to, or CD is equal to, because we want to be able to know what those things are. The only thing is, back from our theorem sheet, we only have the options of AC, CB, or CD.
Just a reminder for any students going out for boys track, all of your forms,
So what we're gonna
paperwork is due by Friday. If you're trying out for field events, you need to make sure your physical is in by Wednesday. Thank you.
So what we're going to do is still use our CD squared. So this is our originally one, but we're going to solve it for AD. So AD times BD. So I know CD squared would be 8.5 squared. And then AD is missing, so that's our W, but our DB is 5. Okay? So 8.5 squared will be our first stop, 72.25, and then is equal to 5W. Divide both sides by 5. We're going to get W is equal to 14.45 feet. Okay? Now, I want the height of the gym wall, which means I need AB, so that is AD plus DB. So 14.45 plus DB, which is 5, gives me 19.45 feet. Okay? So sometimes you don't necessarily need to set it equal to what you're missing. You can still plug in missing pieces and then solve for that missing variable. Okay? Hopefully this video helped you clear some stuff up about how to use geometric mean or how to use similar figures, especially when you're seeing that right triangle similarity theorem. If it did, give it a thumbs up and tune in next time when we discuss more similar triangles. Have a great day.